All right, so the first thing we need to do is we need to complete the square. To get our x squared, our x, we need a binomial squared plus a binomial squared. So we're going to need x squared plus 4x plus something to complete that square. Then we're going to need plus y squared minus 10y plus something to complete that square. And that's going to equal negative 28. Well, if I added something to the left-hand side, I have to add it to the right-hand side. So that'd be plus something plus something. Well, the thing that goes in each of these is our b divided by 2 squared. So that would be 4 divided by 2 squared. That would be negative 10 divided by 2 squared. And what I add to the left side, I have to put in those other two ones over here. So that would be a 4 over 2 squared. And that would be negative 10 over 2 squared. Well, that is, in essence, we're done with completing the square portion. We just take that 4 divided by 2, which is 2, and plug it there. Plus our y, that is negative 10 divided by 2, which is negative 5, so that needs to be a negative 5 here. Squared is going to equal a negative 28. Plus 4 over 2 is 2. 2 squared is 4. Plus negative 10 over 2 is negative 5. Negative 5 squared is a positive 25. Yes?
So even though you divide it and square it, it's still negative?
It is still...
Keep the negatives.
Are you talking about here?
Yeah.
To get to the negative 5?
Yeah, because like negative 10 divided by 2 is 5, but then you square it, so it's become positive.
Yes, but it has to be whatever's inside here. So this has to stay a negative 10 over 2. So that has to stay negative. And it has to stay negative, Gracie, because we need to get a negative out when I actually square this back.
Okay.
Because y minus 5 squared has to equal y squared minus 10y plus whatever we had here. All right, the only way for that to happen is there had to be a negative here. If I got rid of the negative, if I squared it, I wouldn't get this negative back out.
Okay.
So the fact that we have y squared minus 10y automatically means that you would have had to have a negative here.
Yeah.
All right, so that's one way to look at it, is if there's a negative there, it has to be negative down below. All right, so yes, that has to be negative. And then we are going to end up with x plus 2 squared plus y minus 5 squared. And this is going to equal a positive 1 or just 1. Well, that means my center is going to be, if it's in parentheses, it's the opposite. So it's actually going to be a negative 2, positive 5. I'm just going to put a 5, but just know that it is a positive 5. And just so you know your radius, that 2 here is radius squared. So because it's 1, if I take the square root of both things, our r is going to be 1. But if that was 25, you would take the square root, which would have been 5. If that would have been 36 here, your radius would have been 6. If this would have been 49, your radius would have been 7. Your radius is the square root of this number. So this was center negative 2, 5, radius of 1. Hopefully most people that got it wrong were not the ones that were here yesterday. All right. Any questions on the bell work? All right, then questions on the homework. Yes. 53. So 53, we had x squared plus y squared equals x over 2 minus y over 3 minus 1 over 16. So the first thing you really have to do on a problem like that is you have to get all of your x's and y's on one side and anything that's a number on your right side. So that means I would have to rewrite that equation as x squared, I guess that would be minus x over 2. Plus y squared minus y over 3 equals a negative 1 over 16. Well, when I am completing the square, I'm going to kind of picture this as being x squared minus 1/2 times x. Did I have it? Oh, it'd be plus. Okay, yep. It'd be plus because I'm moving it to the other side. Yep. All right. So then we'd have plus something. That's going to complete the square. Then we'll have plus y squared plus 1 over 3 times y plus something is going to equal a negative 1 over 16 plus that something plus that other something. Well, what goes in those something blanks is our b divided by 2 squared. So for our x's, we're going to have a negative 1/2 over 2 squared. And Gracie, just on your point about the negative and why we keep it, if I didn't care about this negative, I wouldn't even put it there because when we square it, it turns positive anyway. So if I didn't care about it, I wouldn't write it. But I go out of my way to write it to remind me that it has to go down here. So that might be another sign to remember that I need to keep that negative sign. All right, our other one is 1/3. So it would be 1/3 over 2 squared. And then we square both those things over here. So over here we would have that negative 1 over 2 squared. And then we'd have our 1 over 3 divided by 2 squared. All right, let's go ahead and complete the squares. This would be x. It is going to be negative. Well, 1/2 divided by 2, if I did keep, change, flip, it would be negative 1/2 times flip 2 would be 1/2, so that's going to be 1 over 4 squared. Plus our y, it is plus 1/3 divided by 2 is keep, change, flip. That is 1/3 times flip the 2, which would be 1/2, so this would be 1 over 6 squared. And that's going to equal negative 1 over 16 plus this would be a negative 1 over 4 squared plus this would be 1 over 6 squared. And this whole side here is just going to equal 1 over 36. I'm not going to do all that work. So that means our center is going to be a positive 1/4 and a negative 1/6 because it's in parentheses, so it's going to be the opposite. And our radius is actually going to be the square root of whatever that whatever number's on that other side. So that is 1 over 36. So our radius is going to be square root of 1 over 36, which actually equals 1 over 6. So that's my center and that's my radius. Does that make more sense? Okay, good. Make sure you get all your x's and y's on one side and your number on the other side, because your number on the other side is going to lead to your radius and everything else will lead to your center. All right, other questions? It's probably a really good problem to go through because that's probably as hard as they get. You had to move stuff to the other side. We had fractions we had to deal with. As long as you're doing the right stuff, you'll get most of your points even if you mess up the fractions. Grace, do you have a question? Okay, yeah. 55C. 55C. We were given the two outside points, right? We were given a point is 3, 5, and the other point on it was -1, -1. Well, if you look at that picture, your center is going to be smack dab in the middle of that circle. So if you look at the answer key, that's why I use the midpoint formula. I use the midpoint formula to find my center because it's smack dab between those 2 points. So let me go ahead and take a picture of that. So we're looking at that C1. So this center is smack dab in the middle. So if you use your midpoint formula, you're going to come up with your center being 1, 2. So that center actually becomes 1, 2. Well, once I know my center, it becomes the exact same problems as the one above. We just need to find our radius. Well, our radius is the distance from 1, 2 to either 3, 5 or -1, -1. It looks like I chose 3, 5. So I did 3 minus 1 squared plus 5 minus 2 squared. That resulted in square root of 13. So our equation would be x minus 1 squared plus y minus 2 squared equals just regular 13 because you'd square it to get your r value. R squared value, I should say. Is that good, or do you have a more specific question?
No, I was just wondering why we used the
Okay, yep, we use the midpoint formula because we didn't know the center, so it's smack dab between those points. So if you ever know 2 points are away from each other like that, then you can get the center by finding the midpoint. Other questions? Okay, today we're going to talk about lines again. So we're going to finish everything off with lines. This is an important section. We'll have, I don't know, 3 or 4 questions probably on the test on just lines, giving you points, giving you lines and saying it's perpendicular, giving you a line and saying what's the parallel line. So this type of information. There'll probably be 2 or 3 questions on the test. And I say that because I don't want you to miss these questions, these ones that just take a little bit of practice. Have as much time as you can to do the word problems. And have plenty of like slush room where you're like, okay, I got everything. All right, the couple word problems, I can mess those up and still get an A on this test. All right, so I want you to really focus on this stuff. All right, so the first one is our point-slope form of a line. Well, your point-slope form, ta-da, has your point and a slope in it. So the equation of a line in point-slope form through the point x sub 1, y sub 1, or x1, y1, with slope m is y minus your y value of your point equals our slope times x minus our x value of that point. So our first example says find the equation of the line through -1, 4 and 2, 3. Solve for y if possible. Did I even want to solve for y? So much extra work. Does yours say solve for y? Yeah, all right. I thought I removed that, but okay, since we did it. All right. So first of all, we need to find our slope. To find our slope, we have to think back at what slope is. Slope is rise over run, which is really change in your y values over your change in your x values. Y is up, down. X is left, right. That's why rise over run resulted from it. So our change in y values is going to be subtracting our 2 y values. So change in y is really our y sub 2 minus our y sub 1. That's how much y changed. And how much x changed would be x sub 2 minus x sub 1. So in the example above, we're going to have 3 minus 4 for our change in y. And for our change in x, we're going to have 2 minus a -1. Now, it really doesn't matter which one you call your second point, which one you call your first point. I usually just, whatever second one is listed, I call that my second point. But what you have to make sure is 3 and 2 better be on top of each other, and 4 and -1 better be on top of each other. If I would have flipped both of these, everything would have resulted out correctly. If I would have just changed the 3 and the 4, then I would have came out with the wrong answer. So your 2 and 3 need to be on top of each other, and your 4 and -1 need to be on top of each other. Other than that, it doesn't matter. All right, so this is going to equal 3 minus 4 is a -1. 2 minus a -1, well, that's actually plus 1 is 3. So -1 over 3 is your slope of this problem. Now, when you're using your slope to put into the equation, it doesn't matter which point you use. You can choose the -1, 4 point, or you can use the 2, 3 point. It doesn't matter. It's going to be the exact same equation. So we're just going to use, let's just go with, 2, 3. That way I'm not plugging a negative in. So we're going to use the point 2, 3. And our slope is -1 over 3. That's all the information we need. Now to put it in point slope form, we're going to have y minus our y value, which is 3, equals our slope, which is -1 over 3, times our x minus our x value, which is 2. All right, to put this into says put it into slope-intercept form. The first thing we'll do is we'll distribute that negative 1/3. So we'll have y minus 3 equals a negative 1/3 x plus 2 over 3. Now we're going to add 3 to both sides. Well, when I add 3 to both sides, I guess I'll do it the long way. So we're going to add 3 to both sides. So we're going to have y equals negative 1/3 x plus 2 over 3 plus 3. Well, in order to add 2 over 3 and 3 has to have a common denominator. So that means we're going to multiply by 3 over 3. So think of 3 as actually being 9 over 3. So that's going to leave us with y equals a negative 1 over 3x. 2 over 3 plus 9 over 3 will be plus 11 over 3. That is in slope point. Oh, solving for y. That's what it says. But if we solve for y, that is in slope-intercept form. All right, if you would have used the point negative 1, 4, you would have resulted in the exact same answer. And if you don't believe me, try it. Plug, instead of the 3, if you'd plug your 4 in, and if you'd plug a negative 1 in for that 2, you'd come up with the exact same y equals negative 1/3 x plus 11 over 3. All right, next thing we're going to talk about is standard form. We're not going to spend a ton of time on it. You don't really use standard form all that much. The big thing about standard form is you have ax plus by equals c with some important facts onto it. First of all, a, b, and c are going to be integers. And a is almost always positive. So a is almost always positive. So unless it says otherwise, you're going to assume a needs to be positive to be in standard form. So standard form, all integers, a needs to be positive. All right, example, find the equation of the line through 0, 1/3 with slope 1/2. And you're supposed to write the equation in standard form. Well, here's the thing. They gave you a point, and they gave you slope. So you better believe you're going to use point slope form to start off with. If they give you, what they give you tells you what equation you're going to use. So we're going to use point slope form. Well, point slope form tells us it'll be y minus our y value, so that's 1/3, is going to equal our slope times our x minus our x value, which is 0. Well, we can reduce that down to y minus 1/3 equals 1/2 x. All right, the first thing we have to do is we need to get our x's and y's on one side to be in standard form. So let's move our x to the left-hand side. So it'd be negative 1/2 x plus y equals a negative 1/3. Now, in one step, I'm going to get rid of both my fractions because they have to be integers. And I'm going to make my x, the term right in front of my x, which is my a value, I'm going to make that positive. So I'm going to take everything and I'm going to multiply by a negative 6. Because when I distribute that negative 6 to everything, it'll make my term in front of my x positive, and it'll make everything an integer. Yes?
Why is it negative 1/3?
It should be positive. Because I knew what it was supposed to happen, and yeah. It's knowing too much, that's the problem. It is, so we're going to end up with a positive 6 over 2, which is 3x. We'll have minus 6y is going to equal a negative 2. They're all integers. Our a value is positive, so it is in standard form. That's pretty much all we do in standard form. Standard form is really just a test question to make sure that you know what standard form is. We don't really use it for much. Usually when we get in something in standard form, we put it in some other form. Because in standard form, you don't know your intercepts, you don't know your slope, and you don't know a point. So you really know nothing in standard form. All right, let's continue on. Parallel lines. Two non-vertical lines in the coordinate plane are parallel if and only if their slopes are equal. So as soon as you hear the word parallel, you should think slopes need to be equal. So our first example says, find the equation in slope-intercept form of the line 1, -1 that is parallel to y equals 3x plus 2. So our original line, its slope equals 3. So the parallel line, that slope will also be 3 because they all have to have the same slope. So our parallel line is going to have slope 3. It has slope 3 and it needs to go through the point 1, -1. And so it has the point 1, -1. Okay, well, let's put it in point slope form, where we have y equals, or not y equals, y minus our y value, which is a -1, equals our slope times our x minus our x value, which is 1. It does say to put it into slope-intercept form. So let's go ahead and reduce it to slope-intercept form. That just means solve for y. So we'll have y plus 1 equals 3x minus 3. Subtract 1 from both sides, and we're going to have y equals 3x minus 4. So you'll see your parallel line will look almost identical to the original line, except it's going to have a different y-intercept. So let's go ahead and graph this and make sure it is, in fact, parallel. So we go down to -4 for our intercept. Our slope is 3, so that's 3 over 1. That means you go up 3. 1, 2, 3 over 1. We go up 1, 2, 3 over 1. We draw our line through there. That line is definitely parallel, and it goes through the point 1, -1. So I must have done it right. So parallel lines, big thing is your slopes are equal. That's the only point I'm getting across. If I ask for a parallel line, and next we'll get to a perpendicular line, the whole point of saying parallel or perpendicular is coming up with your slope. So parallel or perpendicular is really just coming up with your slope, and then I'll give you a point. That is how these problems work. When I say parallel, perpendicular, all you're thinking is slope. Perpendicular is obviously not going to have the same slope because otherwise it'd be parallel. So perpendicular lines, two lines with slope m1 and m2 are perpendicular if and only if m1 times m2 equals -1. In other words, your slopes are negative reciprocals. So perpendicular lines will have slopes that are negative reciprocals. So for example, if your m1 equals a, then your perpendicular slope would be a -1 over a. You flip it and put a negative sign out front. That is how we come up with our slope. So we're supposed to find the equation of the line perpendicular to 3x minus 4y equals 8, and it needs to contain the point -2, 1. Once again, I read the word perpendicular, and all I'm thinking is the whole point of saying perpendicular is to find a slope. So they gave me an original equation, so I need to know the slope of the original equation to find my perpendicular line slope. So our original equation is this. I need to find that slope. So we're going to find the slope. M equals what? Well, let's put it into slope-intercept form to figure out what the slope is. So we're going to go down to -4y equals a -3x plus 8. We'll divide both sides by a negative 4, and we'll have y equals a positive 3 over 4x. Really don't care about the 8, but minus 2. Our important point is the original slope, m sub 1, equals 3 over 4. So if my original slope is 3 over 4, let's talk about our perpendicular line. What is the slope of our perpendicular line if our original equation is 3 over 4 for our slope? Oh, it'd be negative 4 over 3. Yep, it's a negative reciprocal, so this is going to equal a negative 4 over 3. They also gave us a point, negative 2, 3. Not negative 2, 3, it's negative 2, 1. And that means I can put it into point-slope form. Point-slope form would be y minus 1 equals our slope times x minus a negative 2. Well, that's going to give me y minus 1. I'm going to go ahead and graph this. So it'll be y minus 1 equals a negative 4 over 3x. This is actually a positive 2, so it'd be negative 4 times 2, which is going to be a negative 8 over 3. Now I'm going to add 1 to both sides. Well, rather than thinking about adding 1, I'm actually going to add 3 over 3. 3 over 3 is 1, but it just makes it a little easier to add here. Let's go ahead and bring that up here. So that's going to leave me with y equals a negative 4 over 3x minus 5 over 3. Okay, let's graph that. So that means it has a y-intercept at negative 5 over 3. That's not quite 2. It's actually 1.66666666666. But that's going to be about here. And then it says it has a negative slope 4 over 3. So that means I'd count down 4. 1, 2, 3, 4. And I'd go right 3. 1, 2, 3. And if I'd plot that line, that's a terrible plot of that line. This one's not going to work out well. Close enough. We're going to see it looks generally perpendicular. And it looks like it goes through about negative 2, 1. If I would have drawn my line a little better, it would have looked a little better. But it's perpendicular, and it goes through that point. Easy way to check to see if it's correct. All right, questions on parallel or perpendicular? Parallel, exact same slopes. Perpendicular, reciprocal, and negative. So switch the sign that's in front of it. So if this slope would have been, if our original slope would have been negative 3 over 4, it would have become a positive 4 over 3. All right, that's all I have for you. Make sure you know this stuff. Once again, this is just rote memory stuff. This is stuff you just go home, do the homework, and make sure you know what's going on instead of just going, let's copy the answer key and figure it out on Monday night. Quick reminder, there is no corrections on this test. There is no time to do corrections on this test. What you get is what you get. And I'm kind of okay with that because most of this is just linear equation stuff. This is stuff we've had 3 times in a row. We had in Algebra 1, Algebra 2, and Precalculus now. I know we went through it really quick. And why I'm saying it's important because you've already seen it twice. If you're not sure how to do this, you already know if you're not sure how to do this. You weren't sure in Algebra 1, you weren't sure in Algebra 2, so that just tells you, hey, get help before the test on Tuesday, knowing that there's no corrections.